Well, hello and welcome to day 2. We are officially started. Yesterday we're going to do math all week. So yesterday we talked about left off with fractions, right? And that means today we are going to talk about. We'll start with decimals. Decimals. Well, now is not the time to deal with it.
Yeah, I'm just letting you go.
All right. Now I've been informed. Thank you. Okay, we talk about decimals. We have our decimal places. So we have, let's see. I did 1, 2, 3, 4, 5, 6 points. 1, 2, 3, 4. We'll see how I want to go with this. All right. So, as a refresher, this is the ones. Ones. What is this one? Tens. This is the. This is the. Okay. Thousands. This one is the.
Tens.
All right. It's not the ones?
No.
The tens?
Tenths.
Tenths. So we have to spell it correctly. T-E-N-T-H-S. T-E-N-T. Yeah, spell it right. Tenths. Then that makes this one the hundredths. Then this one is the. And this is the 10,000ths. 10,000ths. All right. And of course you probably do well going past thousands. What we hit next? 10,000s, 100,000s, millions, blah, 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 on and on and on. Don't forget that if you are adding and subtracting, that you would always make sure you line up the decimals. Line up decimals. But I doubt that you're going to have a problem with that, because remember, if I had 2.34 and I wanted to add, say, 10.65, I would make sure I go 10 and I would line up the decimal if I'm doing it by hand. But you're probably not going to do that. You're probably just going to use your calculator and hit the little period button right there, the little dot button, and move on and be done. But I feel I'd be remiss if I didn't do that. All right, so let me see. We got that. Funny, I was just talking to my daughter about this, so I'm all skilled up in how to teach this. We're going to be doing a lot of rounding in here. And I cannot ever answer the question, how many places do I round? And that is because it depends on what units you're working in. And we're going to get into that later. But if it were a simple answer, like if I had a number like 10.653264, and you could say, well, what place do you want me to round to? And I could say, well, I want you to round off to the nearest hundredths. That would be very simple, right? Because the hundredths, I want to round to the hundredths, so it's 10 hundredths, so I want to round off to that place. And when rounding off, you're always going to look at the number next to it, and if it is a 5 or greater, you round up. Round up, right? So that would make this not go anywhere. So if it is a 4 or less, this number that I'm talking about rounding stays the same. Stays the same. I kind of realized I was talking to my daughter that people often say you round down, and that really confused her. Well, so that becomes a 4? I'm like, no, it just stays the same. So it's like, well, then the word is it stays the same, right? So if I was going to round this to the nearest hundredths, that would be rounded off to 10.65, right? If I had a number that was, still can't get used to the fact that it does that, and I can't seem to fix it. 9.658, and I said round to the nearest hundredths. That'd be this one, right? Okay, so it'd be 9.66. Okay, So we're good with that, right? But the reason why I can never really answer what do we round off to, and I'll explain that now, and we'll get into it a little bit later. But we're going to be dealing a lot with, in electricity especially, milliamps. And so now that you've been doing the math project across the street, and I'll do much more of this in just a minute, but to talk about rounding, if I said I have 500 milliamps, that is equal to 0.5 of an amp. So some people are over here working in milliamps, and if I said, well, round to 3 decimal places, that's 500.000, and these people over here going, oh, 3 decimal places, that's 0.500. You see the huge difference between the two numbers? So so I can't say, well, round to 3 decimal places, because what unit are you working in? You work in a milli, or you work in amps, and so, people get that are in one and another, and I want to accept everything. So when you ask me how many decimal places to round off to, it's a very complicated question. First I say, well, what unit are you starting with? Are you using amps, using milliamps, using millivolts, using volts? What is your base unit? So what I try and allow you to do is just do it within reason, whatever's reasonable. And so and that's one of the problems with Canvas is Canvas doesn't always want to take what's reasonable. It's very difficult. It's not a math program. So I recommend that you just use paper with as much as you can. And I had this idea that how I was going to do it, but it just didn't work. Yeah.
So if it comes to the rounding, would it just be safer just to use to the thousandth place, just 3 behind the decimal?
Okay.
Just keep it at that?
But
Would that be easier?
well, it's not, because if this half of the room, if the answer is, well, I was a little bit, we're measuring something, and it is 565.2 milliamps. It's a very weird thing to have, but say this, you guys are all like, hey, we're doing milliamps. And so if I said round to the nearest 3 places, you're like, well, I'm good, because it's 565.2, right? And you've done it to 1 decimal place, right? Yes? Okay. But this side, they don't want to use milliamps, they want to use amps. So they're looking at it and go, well, that's equal to 0.5652 amps, so I'm going to round off to 0.565. Who's more accurate? This side of the room or this side of the room?
Well, this said, because we went one further.
You're actually, and I could have went more and more and more. You've actually gone, you're way more accurate. So again, it's like, well, how many decimal places? So then they'd say, well, we got it wrong, and you got it more accurate. And I said, well, 3 decimal places. But we did. And I'm like, well, I wanted milliamps. Well, I can't do that. It would drive you guys nuts. So that's why I say just within reason.
Okay.
Yeah. Also, while I'm thinking about it and on the subject, I will be, standing over you, asking you, to measure something, and you're going to measure it. And don't be ridiculous about your measurements, because people will give me like this, well, that is 1.653 amps or volts. I'm like, the meter doesn't even go that way. It's like it's between 1 and 2, and you're like 1.6532. I'm like, what the heck? It's like 1 and almost a half is about the best you can do on some of these numbers. No, that's off the subject. All right, so we got rounding. Let me see. And of course, I don't think I covered this, but if I were going to round, we'll just take that number, 0.565213559. And I said round to the nearest 1,000, which 10,000. What number am I looking at?
You're looking at 2.
2.
Stay the same.
Okay, so I'm looking at the 2. Is it going to round up or stay the same? Okay, do I care about the 3, 5, or 9? Yeah, you don't. You only just look at the one next to it. Doesn't matter. So make sure you do that. Excuse me.
What if, say, for instance, it was 0.565249.
0.5652498. Like that?
Yeah, something like that.
And you're still going to round it the nearest 10,000?
I mean, I'm saying if that wasn't a 4, say for instance that was a 9.
9.
So like,
998.
be able to round the next number up. Would you still round up?
Yeah, because you just look at the one next to it. That's a 9. 9 is bigger than 5. 5 are equal, so it's 0.5653. It's an airplane. Yeah.
If it was 56249, the 9 wouldn't round that 4 to a 5.
56249.
Yeah.
Okay.
And we're looking for the 2. The
2.
9 wouldn't round the 4 to a 5.
No, it doesn't. No, and thank you for doing that. That's really wanted to bring this up, because we wouldn't then say, well, start over here. The 9 makes that a 5, and it doesn't do that. And the reason why, if we look at it again, 5, 6, 2, 4, 9. If we think about the 4, 9, it's less than halfway, right, to the next number. 49, 50. Now we're at halfway, and the convention is to round up. But if we went the other way, it's 48, 47, 46. It's getting smaller. So if you look at this as the entire number, but we don't need to. We can just discount that and just look at the 4. But it's the same thing. I could look at it as a 49 and say it's less than 50.
So if you had a 9 and a 9, and you're rounding the 9, it would carry over. And so, for instance, if that was 562 or 5699 instead of 24.
5699.
Yeah.
569.
9.
9.
And you're rounding like
The thousands.
10,000.
Here.
Thousands there, yeah.
Okay.
And then you would up 1, and then the 6 would become a 7.
Yep. 570.
Yep.
Yeah.
Would you be wrong if you don't put the 0? Since technically it's after the number.
Oh, you'd be. It depends on whether if the period is here.
0.570,
No, you are not wrong.
just put 57.
Because 0.57 is the same as 0.570, which is the same as 0.570000. No, so you never need to put the zeros there. I'll never look for that.
So even if it's 5, 6, 2, 4, 9, 9, because an extra number after it would bump that 9 and the 4.
So we're looking at this place right here.
Looking at the 4.
Looking at the 4. Okay.
Well, I'm sorry. Yes, the 2.
Looking at the 2.
Yes, looking at the 2. Would we round? Take
Would
all
you
the
round
numbers
it to
behind it.
Would I round it to a 3? No, because I just look at the number next to it, and it is less than 5. Or you can look at the whole thing. 499 is less than 500, which is halfway. All right, you guys are engaged. That's good. So, all right. But again, I don't have a convention of always do 3 decimal places, because again, somebody could be in kilo or the other way, milli, and it just, those are, just makes it difficult. So, but as a rule of thumb, when we're doing some of our problems, especially when we get into AC, and I don't want you to freak out, because I would say when we get to AC, the pass rate of that test is extremely high, right? It seems so complicated, but it's just one simple little thing. We spend an entire week over it until everybody gets it. So it's not to be worried about, but it's it's computations of AC circuits. It takes a while. I mean, you start with this, and you do the next, and the next, and the next, and the next, and everything builds upon everything to this whole mathematical equation. And the more you round, the more off you're going to get. Now, I can see a right answer from a wrong answer, but when we do it, I'll say something like, okay, let's try and just keep our calculator running, not stop and write down a number and round that, and then round that, then round that, then round. It starts to get off quite a bit at the end. So there'll be times when I'll say, make sure you just keep a running number in the calculator with all the places that it gives you, and that will be good. Then you can round your final answer, yeah. All right. And then we did cover this yesterday, but I want to do it one more time here. So converting decimals to a fraction. There's 2 ways to do it, right? Oh, there's more than 2, but decimal to fraction. All right, so remember, first of all, it's just a division. So 3/4, and remember the division sign, it's really just divisions. 3 divided by 4, so you're going to get, what, 0.75? Well, the other way to do it is to, wrong one, is to use your fraction to decimal. So if you forgot or you just prefer, I don't care how you do it. 3 ABC4 second fraction decimal equals, and it's going to come up with your number. So one more time, just make sure everybody got it. So if I wanted to know what is the decimal equivalent of 3/4, I could do 3 divided by 4, which is actually pretty fast, or 3 divided by 3 ABC 4. Okay, my calculator is going to then say 3/4, and then I can hit the second function, second, and then hit the FD key, and it will give you 0.75. Right? Forgot, this section has been brought to you by Bubbly. I get paid for that. I don't. It is pronounced Buble. I know. Thank you. Never going to get that sponsorship if I don't say it right, huh? Okay, let me see. Convert fraction to decimal. Okay, convert a decimal to fraction. There we go. Decimal to fraction. Nope, that was fraction to decimal, wasn't it? It's fraction to decimal. So decimal to fraction then, 0.75. I want to go to 0.75 and I want to go back to a fraction. How do I do that?
What fraction do you want to go to?
Okay, what's the question?
What fraction do you want to go to?
Yeah, what fraction do I want to go to? What is the denominator I want? Okay, well, if I want it just to be in the correct least common denominator, or the that's not the word I wanted, the reduced fraction, the simple way to do it is second fraction decimal, and it's going to show you 3/4. So you plug in any decimal you want, 0.75, second fraction decimal, and it's going to tell me 3/4, and there we go. Okay, but like I said, there just seems to be on the FA test, and certainly I followed suit with a lot of my stuff, is I may want it in something else. So it's what if I want 0.75 and I want to know what it is in eighths? How do I get it in eighths?
Multiply by 8.
Okay, just multiply this times 8, and whatever the answer is goes right there. So 0.75 times 8 is 6, so it's 6/8. So 0.125, and I want that in 16ths. Because you know it's 1/8. So multiply that by 16. I should get what, 2? 2/16. All right. Does that ever come in useful? Yeah, it really does when you're working with rivets, especially. Like I showed you the other day, you end up getting this weird number because you've multiplied the diameter of the rivet. We could do that one more time because that was kind of fun. I thought so. So this time I'm going to use an 1/8 inch rivet. So I'm using an 1/8 inch rivet, and I have a section of 0.040, a section of 0.032, and a piece of 0.25, and I got to rivet all that together. So it's 2 pieces of skin and a rib in there. And I want to know what size rivet to use. And remember, the formula is the diameter. That's the diameter of the rivet times 1.5. So we start there. So it's 1/8 times 1.5 plus 0.40 plus 0.32 plus 0.25 equals somebody's going to tell me what that is. Just that decimal number. What do you got?
0.2845.
0.2845. Anybody disagree? Okay, but I want to know what length rivet I should use. Remember, rivets in length is in 1/16 of an inch. So how many 1/16 of an inch rivet do I need? 4.552. So the rivet size I would use is a 4.5. There you go. Good job. Let's see. I had other things in there. Let me see. This is real world. You're stuck upside down inside the cockpit of a Cessna Citation. I've actually gotten stuck in one. I panic. I'm like, I'm never getting out of here. And you need a bolt. You need a wrench. Now, if you're good enough, you should be able to look at a bolt and go, I can just calibrate it. I can see that I'm going to need a 7/16. But you don't know what size you need. So you can reach over and you can grab your calipers and you put it on there and you measure this bolt. Maybe you can't see it. You just reach up, measure the bolt, and you bring it down to see what size you need to yell at your buddy to go get you the right size wrench. And let me see. Let's say the nut or bolt you're measuring was 0.3123. So you want to know what size wrench you need. What size do wrenches come in?
16s and 8s.
Is it 8s or 16s?
Oh, actually, they come in everything up to about 16.
Well, what's the dimensions? So if you have, think it's small, you have 3/8, 7/16, ½ inch. What are those increments?
16s.
In 16ths. So wrenches come in 16ths of an inch. So what size wrench would I want to yell for somebody to come get? 5/16. Hey, bring me a 5/16. All right, so that kind of works. So you multiply that times 16, going to get 5. So there you go.
4.9. Some change.
Right. Well, you squeeze too hard on the thing. That's all. I want to drill a hole. Let's see. I want to drill a hole that is 1/64 of an inch undersize, and then ream to final. So I have some directions. So drill a hole 1/64 undersize and ream to 0.763. That's something that you'd actually end up seeing a lot in aviation. They want you to use a drill bit, drill a hole, and then drill bits aren't accurate enough, so they want you to get a ream that they're expensive, and it would turn slowly in this hole and enlarge it to the exact size of 0.763. So what size drill bit would I want to use? And drill bits are in 64ths of an inch. 64ths of an inch. Okay, so what is it? 47.8? Let me see.
48.8.
Okay, good. So we're getting there. So, what'd you get? 47?
Not 48.
0.763 times 64 equals 48.8. So 48.8, 48.8. Well, what is that basically then? You're going to round to the nearest size. What would be the correct size?
49.
Okay, so that's going to round because they're going to round up. So it's 49/64. Okay, so we just figured out really what this final size is. It's very close to 49/64, right? But we have to do it, how much undersize? 1/64. So what size drill bit do I want? All right, 48/64. Everybody follow that? It's a very aviation type question right there. So 48/64. What decimal equivalent is 48/64? What is it? 0.75. There we go. Because 48/64 isn't exactly reduced down. All right. So good. We got that. You're doing great. So, all right. So we're going to drill it to a 3/4, and then ream to final. All right, let me do this now.
Can I get one more example, please?
Yeah.
Sorry.
I don't have one. One of the ream ones like that.
Sure, I would just, or you just re-explain, like, I understand the math, I guess
Lost on my example.
yes.
Okay. Well, maybe if I explain the
I was trying to
example.
write down what you wrote before, and then you started on this one, so I couldn't get to it, you're already over here, so I'm like, where did it even come from?
Oh, well, I'm just writing all over the place on here. We talking about the drill bit exercise?
No, the ream, 1/604 pound size, ream.
Yeah, all this right here. All that right there below. Okay. So my example was, I could try and make up another example, but I'm just coming out of my head. Okay, so we're modifying an airplane. We're doing a fix, and this is really common. Let's say you've got a bolt that goes into something, and actually I did do mod on a plane this summer. So a bolt that went in this landing gear, been in there for a long time, and then this started to wear out, right? So this is getting all sloppy. So you pull the bolt out, and the bolt, it looks okay. So putting a new bolt in won't do anything. It's still really sloppy. So now I've got this slop in here. So what I've got to do is I've got to press something in there, bushing in there, right? And then ream this bushing out. So I may have to drill this part out to a certain size, drill it, and then ream it. So let's just say that they want me to drill it. The final dimension is 0.5. Trying to think of an actual ream size you could use. I don't know. We'll just call it 0.5. We'll make it easier. Maybe that's better. So final dimension is 0.5. Okay. So when I'm all said and done, this hole's got to be a perfect 1/2 inch. So what happens is they say, but you have to ream it to 1/2 inch. So I go out and I buy a ream that's perfectly 1/2 inch. When I put that through, everybody know what a ream is? So it's okay.
It's like when you drill a hole and then you make a line.
Yeah, but it's not a drill. It's a very special tool with these teeth on it, and it goes in and sometimes
Oh,
they're
like for like wood, you use woodworking and it kind of like cuts a hole into it? Is it
cuts a
kinda
hole in it. Let me see. Picture.
Cool picture one.
Picture.
So I'm trying to annotate something I know.
Let me see. It's always dangerous playing. Yeah. That's not a piloted reamer, but there's a reamer. That's a good picture. So you see how it's got the flutes on it that cut right there. So so this is precision ground. Each one of these, so when it goes through, that'd be exactly 1/2 inch. All right, so the deal is though, maybe the hole is too small. You can see with that reamer that it's not going to cut right here. It's got to be very close to the right size because it's small right in this little section, and then it's the right size through here. So I can't drill a hole with that. So I got to pre-drill a hole. Well, let's say I want to drill that hole 1/8 inch smaller and then run that reamer through. So what I was trying to figure out is, okay, I want to make it 1/8 inch smaller and then use the reamer. So what size drill bit do I need? So that would be 0.5 minus that 1/8 inch equals what? So we start with that. So what is that size right there? So now I'm using fractions and decimals, so it's easy, but it's 0.5 minus 1 ABC 8 equals, okay, 0.375. Now, if my drill bits are in 64ths of an inch, and by the way, there's drill bits that are fractions, letters, and numbers, so it's more complicated than that. What size drill bit is this 0.375 drill bit in 64ths of an inch? Okay, it's a 24 64ths. Now, just so happens as I'm looking through all my drill bits, I don't have a 24 64ths. Why not? Because it's not reduced. How am I going to reduce that? Well, okay, we could look at it and say, okay, we divide by 2, then we divide by 2, then divide by 2, and we keep doing that until we get it. Or I just use a calculator. Maybe there's an easier way, but I go 24 ABC 64 equals, and it's going to come out to 3/8. Everybody see how to use your calculator? Very simple to get that answer. Okay, now, I do have a 3/8 drill bit. Okay, so I drill it 3/8, and then I'm going to remit my final dimension to 1/2 inch. And boom, there we are. That was a good example. I like that one. Okay. So here's what we're going to do. Stop this, stop that, and let's do this and pause here. Okay. 90 was the average, probably closer to 100 because I know that there's some errors in here. I saw them, but I can't change it once we get going. Okay, so convert fraction decimal. Everybody got that? Everybody got that? So looking great, looking great. I think everybody got this one probably. It's just a rounding issue. It's and I just go through your test. It just takes me a while to do it. Oh. But the answer is 4.0625, and it's at 4.06. Sometimes when I enter in the right number into this, it automatically rounds it for me, and I don't catch it sometimes that it's changing what I've entered. And then it seems to not do it when you do it. It's like it does it to me, and I'm like, oh, well, it's going to round, so then I'll move on, and then you put in an answer, and it doesn't round, and it's like, ah. So 4.0625 is the right answer. Let's see. This is hit and miss here. So let me see. So 10, ABC, obviously you know how to do it. ABC 11, ABC 32. Second fraction decimal equals 10.34375. That's just a very hard one to nail down. I have to go in there and actually write how many places to convert. All right, so convert 16ths of an inch, do not reduce. All right, so how do you get the answer to that? How'd you do it?
Times by 16.
Multiply by 16. So it's 0.1875 times 16 equals 3/16. Okay, can you reduce that one? No. Okay, so that's what I wanted. How about this one, 0.25? Can you reduce that one?
Yes.
But what did I ask you to do? Don't do it. So there you go. All right. So that's what I was looking for. So when I go through this, I have to hand grade it. It'll take me some time, but I'll look for the right answers. Okay, so same thing here. We got that. Everybody got that one. Convert to 16ths of an inch. Do not reduce. So it's 3.3125 times 16 equals 53/16. Right?
Yep.
Okay. So very simple. Convert 16ths of an inch to reduce. Half will be 8. 8, yes, it's right there. All I have to do is look down there. All right. Round to the nearest hundredth. So tens, hundreds. So, all right. One person missed that one. One person missed that one. Round there. So all you have to do is remember there it's 10 hundredths, which place you're actually rounding to. Nearest hundredths.
I missed that one because I added them together by accident.
Oh! All right. Minus, minus, minus. I think when I originally had these set up, I actually said, do not use a calculator. And so I was trying to teach you how to line them up. I thought, well, why am I doing that? That's just kind of ridiculous. All right. So these should be simple. You just punch in the numbers and hit the times. I don't know why you would miss that.
Turned out fine because I left my calculator in the car by accident.
Oh, that'll do it. Okay. See, everything else is just punching it in the calculator. Okay, and making sure you watch where commas and periods are there. Okay, it is officially a break.
What is the correct answer
For which one?
Number 20?
Number 20?
I know, what's the correct answer?
Which one's 20? Last one? Oh, I sorry, I didn't realize it. Everybody missed that one. 2159.65 divided by 6 0.5648 equals point. Ooh, yeah, 0.0328. There's a problem right there for sure.
Yeah, it's a comma, not a point.
Yeah, that's probably.
That's a comma.
I know.
Okay.
I wonder what I wanted it to be.
Have you rounded to 2?
I don't know. No.
Oh, there.
No, it would have been 6.
I'll figure it out. Okay, so we finished up on, was it decimals? Okay. Now we're going to start getting into some more fun stuff. The first part's boring. Second part's fun. Okay, so now we're talking about ratios. So, ratios and word problems. How you guys like word problems? Yeah. Well, wait a minute. A day ago, what did you think of fractions? You hated fractions, right?
No.
Okay. Huh? But they're easy now, right? If I could throw any fraction in the world at you, you'd be like, I got it. Because you got a calculator. So? But you can do it, right? Okay? And that's the whole thing. So, all right. So, a ratio. Oh, well, I was telling you that because I'm going to show you how to do every single FA word problem. There's a formula. It's a hidden formula. It's a hidden way of doing it. And I've yet to see an FA problem where I couldn't apply this simple formula and just knock it out. Every single one of them, without exception. So once you start seeing that, once I show you that, you're going to look at all the FA problems and go, wow, okay, that's really easy. And so you're going to like it. So ratios. So a ratio is a comparison. A comparison of two numbers. Two numbers. It is actually expressed in different ways, though. Expressed different ways. Different ways. So actually, we could have a fraction. That's kind of a ratio. Like 5 to 7, 5/7. It's actually 5 to 7. They may do it in a colon, not the butt kind, but the other kind, like 5. Maybe I don't have to say everything, I think. 5 to 7, that's the colon right there. And the 2 version, 2 as in 5 to 7. Or as a decimal. I hate this one though. As a decimal. So like 15 to 1. So there we have the colon version, which is the more common one. And you try and reduce it to 1, with the 1 being on the end. So 15 to 1. That would be a proper way of doing it. Can be expressed as 0.067.
What is that bottom number? As a decimal, 15 to 1 can be expressed as 0.067.
Can be expressed as 0.067. It is basically because what you're doing, it's like that. So it's 1 divided by 15 equals 0.067. I don't know. I have a harder time with that just visually in my mind rather than seeing it at that. So, okay, so we get to use a lot of ratios in aviation. And we use a lot of them in my classes. So you really kind of got to get used to it and understand what they are and make sure that you're applying it correctly. Can I scroll a little bit? You got to tell me if I go too far. Okay, so let's talk about the application of ratios. Application. Well, first thing we have is we're in aviation, especially in my classes, we talk a lot about the compression ratio. Compression ratio. That's of an engine. So an engine has a compression ratio, which is the difference. The difference between the volume of the cylinder, so difference between the volume try to write nicely, of a cylinder, at, I'm going to abbreviate, bottom dead center, I misspelled it on here, versus top dead center, which is to say that inside of a cylinder we have a piston that is going up and down, right? And so the compression ratio is the difference between the volume that is in the cylinder, usually expressed as a liquid, when the piston is all the way down versus when it's all the way up. So what is the volume when it's down versus when it's all the way up? And so there we go. So that's a compression ratio. It is not something that is changeable. In order to change that ratio, you would have to actually change how far the piston went up or the size of the piston or something. So it's not something a pilot can do. What's that? Yeah, you could change, well, we don't do that in aviation. They're in one piece. That's what I was trying to say without trying to say it. Yeah, change the stroke. We have aspect ratios. Aspect ratio. What's an aspect ratio? Well, what'd that have?
Is it like a wing?
There you go, the wing. So in this thing, it's the ratio of the length of an airfoil, in other words, the wing, to its chord, which is the width. I'll put that here. Technically speaking, the chord of a wing or an airfoil is an imaginary line between the leading edge and the trailing edge. It's the chord line. You'll get that with Phil. So this aspect ratio is the ratio between the length, or I should say, it's how wide out it goes versus the chord, which is going this way. So, like this. So the span versus the chord. So nice. So like a Piper Cub or something like that. You guys know what the Piper Cub is?
No.
Like the ubiquitous little yellow Piper Cub. I should have pictures all over the room with Piper, things like that. So Piper Cub. Well, they're sitting right over there because we painted.
You haven't put them up there, right?
I would not type Pipercub. Piper Cub. Piper Cub. There we go. There's a Piper Cub. Little slow flying little thing, Piper Cub. So it has a very low aspect ratio because it has needs to be modeled. So it has very fat wing. The chord is pretty wide compared to the width of it, versus like a glider. Gliders have.
Sorry, is that like the plane that as soon as you walk in to the left?
Oh God, no! That thing is what is that thing? It's that's a home built. It's Panda or something like that.
It just looks very similar.
Wouldn't be sad if that thing walked away. Sorry if that was your plane. There we go. Real Piper Cub. Okay. No, it's just been here. Or a glider, which has a very high aspect ratio. So, like the U-2 spy plane, that has a very high aspect. What did you work on?
U-2.
I thought so, yeah. The high aspect ratio, right?
Yes.
Somebody told me once that when they're up at altitude, they can barely turn because as they're right at the edge of stalling, because the air up there is so thin, that's true, that when the inboard wing kind of comes back, it tends to want to stall out. So those turns are very, very slow.
Yeah, I heard it was called like the coffin corner, where you have to like keep it within that certain ratio, or you'll overspeed the jet or stall out.
Wow. So high aspect ratio wing on that thing, for sure. Okay. So we had Piper Cub. That was, let's write this, low aspect. And then a glider, or the U-2, which is a high aspect. Now, I would never, this is not like this, remember, so I want to key you guys in. We're talking about math, right? So I would never ask you on a test which one has a high aspect ratio, the hypercover. It's not this subject area. On my test, I stick with the subjects. I just want you to picture it in your head and understand what I'm talking about. So just to make sure you got that. Can I move over? And we're just talking about applications, just kind of getting you used to what are these ratios about. In Aero 312 and 313, we talk a lot about the air to fuel ratio. How much air we have to mix with fuel to get a good and proper burn. I can ask this side, what is stoichiometric?
15 to 1.
There we go. So there's a word called stoichiometric, Stoichiometric. Did I think I spelled it right? Stoichio metric. That's right. Okay. Stoichiometric, which is a fancy word for the chemically correct amount of air to fuel. And for aviation gasoline, it happens to be 15 to 1, where it's 15 parts of air to 1 part fuel. That's gasoline. All right. It can be expressed as a decimal, which is 0.067. And where did I get that? It's 1/15. Okay. Let's see. I can throw in one more. Glide ratio. Glide ratio. Like a Cessna.
Gear ratio.
Oh, we'll talk about that. Cessna 150s, 170s, I think even the 180s have a glide ratio of 8 to 1. So for every 8 feet it moves forward, it will fall 1 foot, or every 800 feet forward, 1 down. Every 8,000 feet forward, 1,000 feet down. So, just for fun. Oh, you guys don't know what this is anymore. The Space Shuttle. The Space Shuttle, for hypersonic, it had a ratio of 1 to 1, and for supersonic, it was like 4.5 to 1, just for fun. What was the one I just heard?
Gear ratio?
Okay, gear ratio. Gear ratio is the hardest one, and that is just teeth to teeth. Teeth to teeth. So we're looking at a gear. It's like how many teeth on this gear to how many teeth on that gear. I don't draw the teeth, but do something like that. So if you had a very large gear with, say, 100 teeth, and you had a very small gear with only 20 teeth, then that's 100 to 20, or you can convert it down, which would be 5 to 1, right? So, all right, so those are all of our ratios. Let me see. Don't think I need to do that. All right, so given that we know what ratios are, we'll talk about solving problems. And these are word problems, really. So solving, well, I'll say word problems. Solving word problems. I'll even write this. Every word problem in the FAA test can be solved as a ratio problem. So in other words, take any word problem they give you, set it up as a ratio, the answer is right in front of you. So usually, and by usually I mean always, usually 3 quantities are known. 3 quantities are known. And the 4th is unknown. So all I gotta do is find the fourth. So here's an example. An airplane flying a distance of 300 miles uses 24 gallons of gas, gallons of fuel. How many gallons? To fly 750 miles. Oops, 750 miles. Right? Absolute typical FAA question. There are three things given, one that is not. So what are my three things? So I know 300 miles, 750 miles, 24 gallons. And so what are they asking? They're asking about the gallons right here. How many gallons? So we're just going to set it up as a ratio problem. Well, first thing you have to do is kind of figure out how you want to do that. So what is my ratio? Well, it's miles to gallons. All right, so once I kind of know that, then I can set it up over here. Well, what do I know? I'm going to put miles over gallons. So I know 300 miles uses 24 gallons. All right? And that is equal to, because we're gonna do the same on the other side, is equal to 750 miles over X gallons. So I'm just going to solve for X. So when you have something like this, to solve for X, we're just going to cross multiply. So cross multiply, we're going to multiply these two numbers and these two numbers. So 24 times 750 equals 18,000. Sounds like a better answer. 18,000. And 300 times X is 300X. Okay. So now we've kind of got that, and this is getting a little algebra here, but this is where we're going. So we have to get rid of the X. How do we get rid of the X? Okay, so we have to, if we divide both sides, the top and the bottom, by 300, because 300X is the same as 300 times X, right? That's what that means. And so if I divide it by 300, I actually just get rid of that, and I'm left with X. So if we divide, so that's how we isolate the X here. Well, whatever I do to the bottom, I got to do to the top. So that's why I divide the bottom by 300, so I get the X. I have to do it to the top, so I divide that by 300. So 18,000 and 300X, and if I divide by 300 on the top and divide it by 300 on the bottom, I end up with X and what? 60. So 60. So X equals 60. Or divide both sides by X, and just X equals 60. So what does that mean then? Well, if X equals 60, that's my answer. How many gallons to fly? 750 miles is 60. So everything is a ratio. Now, I could continue to do this, and we'll do more and more, I suppose, I think, as we go. But the one thing you have to understand is there's an exception to this rule. But it's an easy exception. You just have to remember this, and I don't know how else to make it do. And everything like this, so miles, gallons, or time and miles, everything works the exactly same way except for gears. Gears work the opposite. And the reason why is because if I have a very large gear and a very small gear, which one is turning the fastest?
Small one.
Right, so this one here is going fast. But it's the little number. You know, if it only has 10 teeth and it's going, we'll just say it's going 10,000 revolutions per minute. It's very, very fast. And if this one had 1,000 teeth and it's moving fast or slow? Moving very slow. Well, I couldn't tell you how the speed of it because I'd actually have to set this up as a ratio to figure it out. So you have to remember that this has a large number but a very small number. So it's what we call the inverse. It's the opposite. So I will give you an example. So one that I know. So let me see. I'll write this so that you have it. You can see it in your notes. So gear ratio problems. Gear ratio problems are inverse, the opposite. All right. So speed ratio is the reciprocal of gear ratio. Which means the bigger the gear, the smaller it turns. The smaller the gear, the faster it turns. So it is opposite. As if we go back to the fuel thing, it's like the further you go, the more fuel you burn, right? It's this ratio. More distance, more fuel. Small distance, small fuel. It's the opposite now. Big gear, little speed. Little gear, big speed. So I have to remember that. And I don't know how to tell you that, but just remember that. So write that. Because big gear turns slower than small gear. Whenever I read out like the word "the" right here, because I feel like Kevin on Office. Who are my Office fans? Thought so. I knew you were. You guys don't love The Office?
I say a lot
Never
more
watched
if you were Deep Trade.
Yeah. Why?
Which office?
American.
Yeah.
I hate Michael.
Save time. See World. Sorry if you don't know that. All right. Okay. Here's the thing. Here's my example. A pinion gear. And they do this. It's like a pinion gear and spur gear. It's like, well, wait a minute. I don't know what a pinion gear is. I don't know what a spur gear is. They're two different gears. The pinion is usually the small and the spur, I think, is the big one. But it's not important. It's just a gear with 10 teeth is driving a spur gear with 40 teeth. The spur gear is what? Rotating at 160 RPM. RPM stands for what?
Revolution per minute.
Per minute. Okay. Determine the speed of the pinion. Okay, 3 things are known, 3 things are given, 1 thing is asked. Pinion gear, 10 teeth, 40 teeth, 160. What is speed of the pinion? So they've given me 3, they've asked for the missing link. So again, it's just a ratio. But you're going to set it up just slightly different, but not much different. So I'm going to say pinion over spur equals, don't want to do that. I don't want to mess you up. We'll just, pinion spur. So we'll do that. So pinion spur. So what is my pinion? How many teeth? We'll do teeth first. So it's how many? 10 over 40. Okay. And now if we kept it the same, we would say equals Now, I'm doing it wrong, so I'm just warning you right now. Okay, this is going to be the wrong way to do it. So if we kept it the same, and I just said the pinion, I'll say the pinion on top and the spur on the bottom, because that's what we did before, right? It was like distance over gallons. So if I did pinion over spur, it's 10 over 40, and how fast is the pinion going is what I'm supposed to find, right? And the spur gear is going, what, 160? Okay, so let's cross multiply. So we have 40x equals 1,600? Okay, 1,600. Okay, what do I do to get rid of the x? Okay, multiply both sides by 40. So we'd have 1,600 divided by 40 equals 40. So if I divide both sides by 40, what do I get? I don't trust you for a minute here. 160 times 40 equals... Yeah, this is not the right answer. Why are you guys yelling right answers ever? Huh? You cross multiply. Oh, yeah, my bad. No, I'm my ass. Okay, going this way. 1600. I can see that. Okay, so to solve this then, yeah, no, to solve this then, okay, so I cross multiplied. Make sure everybody's aware. Cross multiplied, right? So I ended up with 44. Geez. It's getting late. Okay, cross multiplied, I get 40x over 1,600, right? Okay, remember, I'm doing this wrong here for a minute. And then, because I'm keeping the pinion on top and the spur on the bottom. And so to get rid of this, I divide both sides by 40, right? So 1,600 divided by 40 equals 40. So it's x equals 40. So what is that telling me? In this example, because somebody's going to do it this way, what is the speed of the pinion? What am I going to be writing on my test? 40. Okay, now let's think this through. The pinion gear with 10 teeth is rotating at 160. Okay? But now, is that right? Pinion gear, 10 teeth. It's hard to do it wrong. Okay, so the pinion gear with 10 teeth is turning how fast?
Spur gear with 40 teeth is turning at 160.
Huh? I said it's 40, right?
40, yes.
Yep. So 10, it's RPM is 40, right? And then the spur gear, which is spur gear has 40 teeth. 40 teeth is spinning at 160. So now I've got the big gear with 40 teeth is spinning really, really fast, and this little tiny gear is suddenly turning slow. Now, does that make any sense whatsoever? Huh? So that does not work, right? Okay, so make sure you stop and think about this. Wait a minute, did that make sense? Does my answer, that's why I always say, when you're taking a test with me, do I need scratch paper? Man, I won't take a test without scratch paper because I think on it. I draw pictures. I'll draw a big gear, then I'll draw a little gear, and then I'll draw the numbers, and I look at it because, and you guys tell me that you're tactile learners and you're closer to visual and you want to put your hands on stuff. It's as close as you're going to get. So build it on a piece of paper and look at it. Go, okay, that gear's turning. That's not right. It doesn't work that way. Okay, and then that would include you in like, oh yeah, there's the inverse. So now let's just do it the right way. So here we have, we'll do the pinion in the pinion over spur. Okay, so that's fine for now. Pinion over spur and pinion teeth. I should figure out a way to do it like pinion teeth over spur teeth equals spur RPM over pinion RPM. I like that. That's what it would look like. So see how it went backwards? So pinion teeth, if I can do this right, God help me, 10 over 40 with the speed. Whose speed did I get? I had this the spur gear speed, right? Which is 160. And I wanted to know what the pinion was, right? Got to flip that second one over. So it looks just like this over here that I did wrong, but I flipped it. So it's 1040, 160x. Everybody see that? How I flipped this over here, down here. So now it's flipped. So when I cross multiply this time, I'm going to get 10x over 160 times 40, which is 6,400. Okay, that's looking a lot different. Okay, divide both sides by what? 10. And so I get x equals 640. Well, that's a whole lot different than the 40 we had before, isn't it? So now if I want to draw this out a little bit, I got a, call it the pinion, and we'll call it the spur. We'll do it that way. And we'll say this one is, was it, I was thinking teeth. So 40 teeth versus 10 teeth. And this one is now moving at, what was it, 10? What was my RPM? Was it 160? 160. And this one is 640. Does that look right?
Yes.
That looks much better, in spite of my inconsistencies. Okay. So remember, swap them around. What's that? Well, let's look at it one more way. What is the ratio of the teeth of the big gear versus the little one?
4 to 1.
4 to 1. What is the speed ratio between here and here?
4 to 1.
4 to 1. Imagine that. Because I guess, well, not I guess, I know that another way of looking at this, and I think maybe the way I was taught was to look at it that way, and maybe your brain works that way too. And you could do that, and you could look at the ratio, and you could say it is 10 teeth to 40 teeth, which is 4 to 1. And therefore, if the RPM that's given, what's my given RPM, is 160, and it's also 4 to 1, then it's going to be either 4 times smaller or 4 times bigger. You just got to figure it out.
I don't know, it's just how my brain does it. I don't care about the teeth, just get to the gear ratio, and then if you know the speed of one or the other, then you can get to it by either dividing by that gear ratio or multiplying by that gear ratio.
Well, that's what I just said. But then I go back to every single problem can be done with a ratio. And some people get a little bit lost if they have to. So you can, in spite of the fact that I'm like flopping all over the place here, you can always just set up your ratio and just remember what I said right there. Is this the one I liked? Yes. Right there. So there's your ratio. Pinion teeth over spur teeth, spur RPM over pinion RPM, just flip them because everything else is going to be a straight ratio. So, all right, what time is it? Okay. What?
9:05.
So I'm going to unlock the ratios quiz. Yeah, I'm definitely going to do that.